stealth technology and its applications in aircrafts. What is stealth technology? Scientifically known as low observatory, used in military aviation, reduces detection range of an aircraft similar to camouflage tactics used by soldiers. Partial invisibility to radar and other detection. Radar signature. A radar signature is how big the airplane on radar appears from a specific angle and distance. Radar cross-section (RCS). The cross-sectional area of a perfectly reflecting sphere that would produce the same signal reflection as would the object. Depends on many parameters, like relative size versus wavelength, target material/painting, shape/orientation. The size of a target's image on radar is measured by RCS. Uses the principle of reflection and absorption as well as redirection. Minimizes heat and other emissions from engine and other spots. Reduces RCS by surface designs of stealth aircrafts by RAS or RAM. How it reduces RCS? The job is performed by using mainly two techniques. 1. Designing of surface. 2. Radar absorbing materials (RAM). But nowadays one more technology known as plasma stealth technology is also employed. Surface design. The goal of stealth technology is to make an airplane almost invisible to radar. Most conventional aircraft have a rounded shape, which means that no matter where the radar signal hits the plane, some of the signal gets reflected back. The shape of a stealth airplane is designed in such a way that it reflects the signals away from the radar, as shown in the figure here. Precautions in designing. Sharp edges. Design of nose. Acute angles. No right angle. The aircraft must bury the engines within the wings, for example Lockheed F-117 Nighthawk. Northrop Grumman B-2 Spirit has a completely different design. It has one big wing, like a boomerang. This flying wing design is much more efficient than a conventional plane, as shown. Differences between normal aircraft and stealth aircraft. 1. Tail angle effect. A corner reflector is retroreflector, which consists of three mutually perpendicular, intersecting flat surfaces, hence reflects and waves back to source. So tail angle should be kept acute to decrease detection, as shown below. 4. Exhaust plume. Exhaust plume of a normal aircraft, stealth aircraft without exhaust. Difference in aircraft design when we are using normal shape when using stealth technology. Engine position. Normal fighter plane showing the engine. Engines of the stealth aircraft are covered. Radar absorbing materials (RAM). Nanostructural composite material, absorbing without reflection radar wave. Magnetic ferrite-based substance. RAM reduces the radar cross-selection, making the object appear smaller. Radiation absorbing honeycomb structural material, usually incorporated with skin of aircraft. Frequency selective surfaces (FSS). Planar periodic structures that behave like filters to electromagnetic energy. They are like metallic screens with frequency selective properties used as spatial filters through which a specific range of energy may be propagated. Lockheed Martin F-35 Lightning II uses new stealthy radar absorbent material in its construction, which includes fiber mat. Plasma stealth. The Russian scientists propose to create a plasma formation around protected object. The aircraft injects a stream of ionized gas in the form of plasma cloud. Prevents radars from seeing it by absorbing the radar energy in this plasma cloud. The artificially created plasma cloud surrounding the plane reduces its RCS by a factor of 100. Infrared stealth. Infrared radiation are emitted by all matter above absolute temperature 0 hot zones, such as engine exhaust, wing surface, friction due to air get heated, which rather increases the visibility. These parts should be kept cool as possible if can be. Option would be mixing of cool air with the hot engine exhaust. Use compressed gas or liquid nitrogen to cool their internal parts. Stealth technology today. The F-117A, B-2 and B-1B can be regarded as the three emblematic low aircraft of the late '80s. The famous F-22A Raptor, first flight in 1997, production ended in 2011, with 195 planes built. 182 planes operating today is a Lockheed Martin's LM 5th generation air superiority stealth fighter. The Lockheed Martin LM F-35 Lightning II, a multirole 5th generation fighter with stealth capabilities, first flight in 2006, currently in initial production and testing. The Sukhoi Pak-FA, a 5th general, multirole, twin-engine jet fighter, developed by Sukhoi for the Russian Air Force. Its prototype, T-50, flew for the first time in 2010 based on Pak-FA. Sukhoi will develop with HAL Hindustan Aeronautics Limited, the 5th generation fighter aircraft, FA, for India. Stealth technology and future. Although US is the dominating country having most advanced stealth aircrafts, but advantages reduces the causality rates during war, saving military budget. Utmost importance in anti-terrorist operations. Develop the military secrets. Bluff the anti-detective device. Stealth aircraft are invisible to radar. Actually a fight between radar technology and stealth technology. Disadvantages. Still not a guaranteed technology, not much reliable. Most of the stealth aircrafts can't fly fast. However, technical advancements remaking them capable of it. They are not maneuverable. Can carry only limited amount of payload. High cost of maintenance. Very economic. Reliability hugely depends upon the tracking radar system. Conclusions. The technology of future. Lots of opportunities lies for scientists, researchers as well as for students also. Success yet to be proved extensively. Huge investment is required. Opportunity for developing countries to learn the technology. Consider as a war between radar technology and stealth technology. US is the leading country, with other countries also investing a huge amount of their investments in the technology.